Rules of differential equation. 1. We have differentiation of x raised to the power n. Okay, so let us assume that y is equal to x raised to the power n. Then dy dx is going to be the multiplication of this power, the power of x, which is n, by the whole term, so which is n x raised to the power n. Then we decrease the power by what? 1, which is minus 1. And for all n belonging to R, real numbers, right? Then the second, we're going to be talking of differentiation of AXN. Okay, so the differentiation of AXN. Again, let us assume that y is equal to ax raised to the power n. Then the first derivative, dy dx, is going to be the multiplication of a by ax. Then we decrease the power or the exponent of x by 1, just as we did in the first rule. Now, according to the first rule, the coefficient of the xn or x raised to the power n is 1. But looking at the second rule, the coefficient of x raised to the power n is what? A. Over here we have only n because when I multiply the coefficient of x by n, I'm still going to get what? N. Over here the coefficient of xn is what? A. So when I multiply n by the a, it's going to be what? Na. Then I decrease the exponent or the power of what? X by what? 1. For all a n belonging to what? Real, and a is, let me put a, and a is what? Is a constant. A is a constant, right? Let's talk about the third one. The third one, we have differentiation of a constant. Now, for the differentiation of a constant, let us assume that y is equal to c. Then dy of dx is going to be what? 0. And then for all c belonging to what? Real. But why is the differentiation of a constant 0? That is what I want us to look at. So the differentiation of a constant is equal to 0 because note x raised to the power 0 is equal to what? 1. Okay, I want us to look at why the differentiation of a constant is 0. Actually, it follows, the 3 follows the rule 1, but let us see why it is 0 actually. So if, let's say, the y is equal to c x raised to the power 0, because x raised to the power 0 is 1, that's why we see only c here. So when I multiply c by 1, I'm going to get what? C. But using the first rule to find the first derivative of y is equal to c raised to the cx raised to the power 0, then the dy dx is going to be, we looking at the first rule, we multiply the coefficient, the exponent of x by the coefficient of what? X, and then we decrease the exponent by what? 1, right? So here the power is what? N. We're going to multiply everything by n, and we decrease this n by what? 1. So looking at the y is equal to c x raised to the power 0, we're going to multiply everything by what? Because c is a constant, we're going to multiply everything by 0. So 0 dot c, then x raised to the power 0. But you know, when I subtract, we're going to decrease this power by 1, right? So minus 1. 0 minus 1 is the same thing. Look, when you multiply 0 by anything, what do you get? You get 0. So because here is 0, 0 times c x raised to the power minus 1 is going to give us what? 0. So in a nutshell, the derivative of any constant is going to give you what? 0, right? Good. So having done that, let us take some examples to appreciate the concept. Examples. Find dy dx. Okay, if y is equal to x raised to the power 5. So to find the first derivative or the dy dx of y is equal to x raised to the power 5, you can apply the first rule to it, which is y is equal to what? X raised to the power n. So it means our n over there is what? 5. So we're just going to obey this rule. You multiply 5 by xn, and then we decrease the 5 by what? 1. So here we're going to have solution. Dy dx is going to be 5, you multiply the whole of this by 5, x, then 5 minus 1, 1. And this will be equal to 5x. Now 5 minus 1 will give us what? 4. So simply, therefore, dy dx is equal to 5x raised to the power 1, 4. You see that? Let's say that is example 1. Let us look at another example, which probably we can apply the second rule to it, right? Okay. So we have find dy dx if y is equal to 3x raised to the power, let's say 6, right? 6. Right. So to find the first derivative of y is equal to 3 raised to the power 3x raised to the power 6, then we can use the second rule for that. And the second rule says that if you have y is equal to, let's look at it, if we have y is equal to ax raised to the power n, where this a is a constant and then this 3 is also a real number, then just multiply the exponent by the term, which is n by ax, right? Then we decrease the exponent by what? 1. We're going to apply the same thing here. We're going to have dy dx equal to, you multiply 6 by 1, 3x raised to the power 6. Then we decrease the exponent by 1. Okay, and 6 is going to give us what? 6, 18. Then we have x, 6 minus 1, the exponent. 6 minus 1 is going to give us what? 5. So simply we have dy dx is equal to what? 18x raised to the power 5. Okay, now let's look at another one. So you see this one is example 2, example 3, example 3. Let me bring this line down. Example 3. Find f of x, f prime of x, if f of x is equal to 6, 9, 3, 2. Solution. Right, so over here we're going to apply the third rule. We say that the differentiation of a constant is going to give us what? 0. So once your function is a constant, then the derivative of that function is going to be what? 0. And I think I've already explained that. Right, so over here, this one should move. Let's grab it, and this one should come down. Okay, so over here, the f prime and f prime, as I told you. Okay, let me do some amendments here. Y is equal to what? Fx. Okay, because of that, dy dx is also equal to what? The f prime of what? X. Okay, so the f prime that we have here is the same as the first derivative, right? I think we spoke about that in the previous video, so if you have an issue with that, try to check out the previous videos that you've already worked with. And here, the first derivative of the f of x, since f of x is a constant, it's just going to be what? 0. You're not going to do anything. Alright, so find y equal to, find dy dx. Okay, find dy dx if y is equal to 9. Simply solution. Because dy dx, because y is a constant, y is equal to 9 and 9 is a constant, and the first derivative of it is just going to be what? 0. And if you find this video interesting, you subscribe to the channel for more research. Thank you.